In this series of videos I'm attempting to repair and restore this Osborne OCC1 vintage computer. In the video so far I've carried out a few repairs to the machine itself, refurbished the two disk drives, repaired one of them, carried out some repairs on the main board, and then I moved on to the keyboard, which was causing me a lot of problems. So I completely dismantled this, took the key panel itself apart and modified it to try to get the keys to release. Basically some of the keys were taking turns effectively sticking down, and it's just the panel itself was causing problems. So I've started reassembling the keyboard, as you can see. I'll just turn the machine on. Wait for the display to come on, and I'm going to turn off one of the lights to reduce the flicker from the display. And the way I've been going about testing this is, as I fitted the keys, I was pressing them, and I don't know how well this is coming across because of the interaction of the camera and the display, but the idea is that when I press the key I should see some flickering on the display. But not all keys will do it, of course, because it depends on what the key's actually going to do. So what I should be able to do is go through and press the keys and we should see flickering. And so that's what I've been doing. However, I've got to the point where really I need to also test the keys that don't cause that behaviour, and some of the keys, such as the numeric keypad, don't cause any flickering, and it's not because the key is open circuit. Now I can of course still remove the plastic plunger even after I've welded these keys back to the aluminium plate. It'd just be easier to do this as I proceed. I also need to get the machine to boot anyway, so that's what I've turned my attention to. Just turn the light back on. So when I bought this machine it didn't come with any floppy disks, so I didn't have anything to boot it to, and I didn't have any compatible disks made up. And because of the way the Osborne works, it will only boot into a very limited monitor program, and really the only thing the monitor can do is put up a message on the screen and then try and boot from a floppy disk. It normally boots to CP/M, although you can run other programs or other systems on here as well if you can get them. So I went onto eBay and I bought a boot disk, and that's the one I showed previously, and it was booting to what appeared to be a selection menu on this disk. And I couldn't really do much at the time, or at least initially, because the keyboard wasn't working, so I was fooling the machine into trying to boot from floppy disk by shorting out a couple of the pins on the keyboard connector. But then I couldn't really do much beyond that, of course, because I couldn't select any of the options. I could have started messing about figuring out which pins to short out, but that would be a very long-winded process, and as I needed the keyboard to work anyway I turned my attention to that. However, when I then subsequently put the disk in and tried to select one of the options using the keyboard, now that it works, it didn't work. It booted to the same selection menu, but when I pressed one of the option keys, just one of the number keys, the system crashed and this disk will no longer boot. So I thought and also I should say at this point that what I generally do is I will disable the write gate on the floppy disks until I'm sure the system can work. Now it does mean you can't save any of the configuration options for CP/M, but you should still be able to get the machine to boot up. So I was fairly certain that the disk hadn't been written to. So what we'll do is we'll go and get the CryFlux system out, which allows me to do very low level reads of floppy disks, and we'll have a look at this disk and try and figure out what's going on. I've got the CryFlux software connected to a couple of 40/80 track drives. I've selected the first drive, we'll calibrate it. So it'll just take a few seconds to calibrate. This just makes sure that the software fully understands the geometry of the drive. Okay, we'll now take the floppy disk in question and put it into the drive we've just calibrated. So there's no question the drive doesn't understand what it's supposed to be doing. And I've got this set up so that it is looking for the correct type of information. So if we select the type of image that we expect there to be on the disk, so this is a double density disk, and we're going to look at the raw data, the low level data. So we're looking at side 0, and there's 1024 bytes per sector and 5 sectors per track. That's the geometry we should have in a double density floppy disk for this machine. And what we can now do is try and read the disk. So if we give the test a name, so we'll call it test 12, I'll hit start, and the system will now try and read the floppy disk. So you can see the first 3 tracks are okay. Now the reason it's skipping over certain tracks is because CryoFlux kind of assumes double-sided drive, so it's skipping over every other track because that would be on the other side of the disk, and this is a single-sided disk. But you can see we have an issue with some of the sectors on some of the tracks. So mostly it's okay, but we've got a problem here, and it's a bad sector, and we've got another one here that has some bad sectors in one of the tracks. So I'll stop that because it's already failed, but you can see that although it's identified on this particular track that it's MFM, which is correct, and that's logical track 8, and it's got the speed right, so it's identified everything correctly, but it's saying that it can't really read that track successfully. And the previous track, track 6, is just a bad sector. It's failed to read the track at all. Now you can create a log file while you're reading the disk, which I have done, and the information it's giving out is it's basically saying that the 2 tracks, they weren't written over, so the system didn't try and write over them, which is what I first assumed. What's actually happened is the disk itself just seems to be corrupt. So I think it's one of the issues you get when you buy cheap disks off eBay. So for a start, trying to write high density information, double density information onto a single density disk is not a good idea. It doesn't always work. It can give you kind of flaky behavior, but in this case it definitely is not working. So we'll go back to the machine and I'll show you what I've done as an alternative. I would say I did contact the seller, and we came to an arrangement where he would sell me some replacement disks fairly cheap. That was over a week ago, and I still haven't received them, and I'm getting a bit impatient waiting. I want to get this project finished. So I decided to take an alternate approach. I only really bought these off eBay to save me a bit of time. But so far it's just wasted a week, so that didn't really work. But we'll go back to the machine and I'll show you what alternative I've selected. So looking back at the machine, clearly we can't use the floppy disk. That's not really going to work for me. Also, when I get to this sort of stage in a rebuild or repair, I try to come up with an alternative if I don't have a way to make copies of the floppy disks. Now normally of course we'd use the machine to make copies, but because we can't boot the machine we can't do that, and it won't boot using this. Now I would say that the image I got off CryoFlux I try to put into this. Now if you don't recognize this, it's Gotek, and it's a floppy drive emulator. So effectively what you do is you get your floppy disk image as a file, you put it onto a memory stick, a USB stick, and you plug that into the Gotek, and then you should be able to boot from the file as if though it was a floppy disk. The machine shouldn't know the difference. Now there are a couple of complications doing that with the Osborne. The first one is, for some peculiar reason, rather than use the standard drive electronics that came with the drives, these are standard drives, but the PCB, the one that we looked at previously, is not a standard drive PCB for these drives. It's one that Osborne seem to have done themselves. And one of the decisions they made was to do away with the separate power connector that you would normally get on a floppy drive. So that's the 4-way Molex or whatever connector that you'd normally plug into the back of the drive to provide it with power. So what they did is they had the power come down the ribbon cable. Now the problem with that is that on a standard floppy drive, say 34-way ribbon cable goes on to a 2-row 17-way by 2-row connector, which is the connector you'd normally get on the back of the floppy drive. But the connections on the underside of the drive are normally all grounds. They're normally all connected together, and the signals are the connections along the top. So if we look at an adapter, so the back of the drive will have a connector like this on the back of the control board. All the pins on the underside are ground, and the pins along the top are these signal pins. And the problem with that is on the Osborne drives, the pins on the underside are in groups. I think the first group is a group of 5, which are ground. Then I think it's a group of 4, which are 12 volt, another ground pin, 3 pins that are 5 volt, and the rest are ground again. So if you just plug the standard drive from an Osborne into another machine, you probably blow something up because you'll short out the power supply. Which is obviously a very bad thing. So kind of strange, and by the same token, don't try plugging another drive into the Osborne. If it's a non-standard drive, you'll blow up the power supply on the Osborne, because again you'll be shorting all the power rails together. So what I did is I have a drawer full of this standard type connections that go like this, but they have a breakout board instead of this molded in connector. And what I did is I modified it to allow me to do 2 things. One was so that I could plug it into the Osborne without blowing the Osborne up. The other one, as you can probably see at the back, is I brought out the leads or the connections for the power, so I now have access to the power coming from the Osborne, so I could power the Gotek directly from that. I don't need the 12 volts, but I did bring it out anyway. That's partly for test purposes. But the next thing is how to get an image for this. That's the second issue, because you need to make sure that the information on this, once you've got the Gotek properly configured, it needs to be configured in a certain way. So I spent some time and I put together what I believe should be a bootable image that I should be able to put into the Gotek, and I should now be able to select it. It has come up. You probably can't see this, but on the display of the Gotek it's come up with the image name, and what we'll try doing now is booting the Osborne, and we'll see if we'll boot to the image in the Gotek. The 2 disk drives are connected, by the way. I'm just using a single Gotek on the Osborne ribbon cable. So we'll hit return and we'll see if anything happens. So let's put this so you can see it. It's doing something, you probably can't hear it. It makes a kind of ticking noise as it's going, so it looks like we're actually loading CP/M. It's upside down, of course, but okay, we've now booted into CP/M. So it looks like the Osborne itself can actually boot up to CP/M, so that's a win. It's unfortunate I wasted a week with the floppy disk, but I still need to make up some floppy disks, but of course I can now do that using the CryoFlux from the image I created for the Gotek. So I can now produce my own floppy disks, and it's a very good way to test the machine, because I'm not risking any more floppy disks and it doesn't waste time. As I say, I only bought the floppy disk to save me the trouble of doing this, but in the end I think I spent 30 minutes making up the adapter and the image for the Gotek, as opposed to waiting a week for the disk to turn up, so it probably wasn't a good trade-off in trying to buy one. Okay, well that's good. We're looking like we're actually getting somewhere now. We'll try pressing a key and see what happens. So we'll press. Okay, well that's looking very promising. It's looking very much like we are working. Okay, now it's upside down, so I won't go any further, plus the flickering of the display is probably very annoying. In fact, I'll turn one of the lights off and hopefully it will reduce that a bit. But as you can see, we are now getting some proper behaviour from the machine. I can go through the various menus, and this is the first time I've tried this, so I'm quite pleased it's actually got this far through the boot process and it hasn't actually crashed yet, so that's another positive sign. I'm going to put some more images on the Gotek, because what the Gotek will also let you do, if you're not familiar with these, is there's a selector knob on the front, and I can select different images, a bit like swapping the floppy disk. So I'm going to put some diagnostic images on the Gotek, and then I can start running the Osborne through some proper tests. And there are quite a few available that you can find online, but the image type you need for the Gotek is an IMG, and there are various utilities such as SAMDisk that you can use to convert from IMD to IMG type files. In fact, it converts them to raw files, and then you just rename them to IMG and then it should work. But make sure you get the Gotek adapter sorted out first, otherwise, as I said, you'll blow something up when you try and plug it in, because it will short out all the power rails. So don't just take one of these standard adapters and plug it directly in, because all the pins on the underside are joined together and they go to the plus 12 volt, plus 5 volt and ground connections out of the Osborne, so you will destroy the power supply. Okay, that's it for this video. Clearly I'm making some progress. In the next video I'll flip the machine the right way up so we can actually read what's on the display, and we'll run through a few diagnostic programs and see if there are any other faults in the Osborne that we need to address. I can also now use this to fully test the keyboard, and then we can start to reassemble it.